Hello and welcome to my channel. I'm going to do a video response for Stuart Lindsay here. Now, his response was basically an explanation of why we are dense. Now imagine a car in place of the moon. Well, I'm sorry. For this explanation, let's pretend we're at the equator. Now imagine a car in place of the moon driving the moon's path around the Earth. Your view would be the underside of the car. It would rise due east, headlights first, front of the car pointing straight upwards. As it goes overhead and sets in the west, it will set headlights first, facing directly down. But the car at no point cartwheeled, it just orbited while we stayed in the same spot of your view changes. Well, guess what, Stuart? The moon is cartwheeling. And it's not just the moon. It's the sun. It's our planets. It's our equatorial constellations like Orion. I'm not talking about circumpolar. Like the Big Dipper, it should rotate around the North Pole. Let's just let this sink in a little bit there for you, Stuart. Think your explanation there. You said it would not cartwheel. Huh. Okay. August 2020. A little later on the same day. A little later on the same day. Cartwheeling moon. There's the other. February this year. Yeah, cartwheeling moon. It's going wax to wane. Wax to wane one night. From our point of view. Well, let's get to the good ones now. Okay. Oh, let's do this. Okay. Here's how. Now this is going to be in reverse because I'm backing up, but here's how sunspots go around the sun as it turns on its axis. I'm going to go forward now just to give you. Here's how they travel around the sun. And that's proven. That's no secret. But then you take pictures of it now from Earth. Not from a satellite, from Earth surface. Pay attention here. Look, we got sunspots. Sunspots, sunspots, sunspots. Here's arrows. I circled the sunspots. As you can see, the sunspots are cartwheeling. Does that match what the satellites say they're doing? Now, these are obviously not the exact same sunspots, but it proves my point. The yellow arrow showing the direction of the spin from our perception here on Earth. Your little model doesn't work now. Actually, it's never has been correct because for my I'm 43, and for the first 33 years of my life, the moon rose and set in the exact same orientation every day. It never cartwheeled until now, since 2010. Okay, so there's the sun. I showed you the moon. Let's just go with Jupiter. Let's just shrink that down a little bit so I can get the other one in here. Jupiter. Got the moons around Jupiter cartwheeling. Man, your explanation's getting weak. Another time. Yep, these are see, this is July 26th. These are July 23rd. So, the moons are. I don't think the moons are going around Jupiter. It's us. Our perception has changed. man, we got the sun, we got Jupiter, we got the moon. I wish I had pictures of Orion, but I don't have that yet. I just can't get pictures of constellations with an iPhone. And obviously, I didn't get those Jupiter pictures and the sun pictures. But so, by your explanation, the car and the moon should rise like this and set like this. No. The moon should rise like this and set like this. Not do this like it is. Okay, I keep getting questions of, can you explain what has happened, why the moon is cartwheeling? Okay, so the Earth, I put little pins in, show the poles. North Pole, South Pole. 23, our normal 23.4 degrees of tilt. Okay, the moon is traveling around the equator. That has not changed. Okay, so what has happened is the Earth has gone on its side completely. The poles are now at the ecliptic plane instead of perpendicular. They are now parallel. So, when you're looking at the moon that is still orbiting at where our equator was, still orbiting the same way, that hasn't changed. But as we spin on our normal night and day axis, same as this, normal night and day, this is how we get night and day. The sun is the monitor shining light on the globe in my hand. That has not changed. The only thing that changed is the Earth tilted on its side and is still spinning the same way it was on its axis, on its vertical axis. So as the moon is still orbiting in the same location on the ecliptic plane, guess what? What's North America doing? Well, let's do it correctly. The way the Earth is spinning from the northern hemisphere perception. Yeah, what's cartwheeling? Southern hemisphere. So we got to turn it the other way because the southern hemisphere sees a counterclockwise cartwheel. Oh. So it's not hard to understand. We went from this 23.4 degrees to additional 66.6 degrees to now be 90 degrees opposing the ecliptic plane. Still spinning on its axis. It's not a wobble. We're not wobbling back and forth, making the moon spin. It's our night and day axis, spinning as usual, making everything along the ecliptic plane now cartwheel. The moon's doing it, sun's doing it, planets are doing it, constellations, equatorial constellations are doing it. Check out Orion. Watch Orion do it. It does it. Okay, there you go. Stuart, you're half right, but you need to go outside and look for yourself and realize what's going on. Think back. I don't know how old you are, but I don't know, maybe you're 20 years old, and if, as a 10-year-old not really paying attention to the moon, you would think it's normal now. But I'm 43, and I paid enough attention with the moon to know that the first 30 years of my life, it always rose and set in the exact same orientation. And now it's doing cartwheels every night at 15 degrees an hour from our perception here on Earth.